Welcome to Tomorrow Unveiled, where we decode the future of technology in space before it hits the mainstream. Imagine this, it's early March, and somewhere in Florida, the most powerful rocket NASA has ever built is sitting on a launch pad, fully fueled and ready to send 4 astronauts on a journey that hasn't happened in over 50 years. They're heading around the moon, not to land, not yet, but to fly past it, loop around the far side, and come back home. It's the kind of mission that used to belong strictly to the history books, but right now it's about to become real. Here's what makes this moment extraordinary. Artemis II isn't just one mission in isolation. It's the epicenter of a massive shift in how humanity approaches space exploration. While NASA's preparing for crewed lunar missions, SpaceX is launching constantly. Private companies are planning space station missions. Europe's building lunar modules. Satellite mega constellations are expanding. The entire industry is accelerating. Today, we're breaking down everything happening in this pivotal moment. From the breakthrough that just cleared NASA to launch, to the commercial revolution happening in parallel, to what it all means for humanity's future beyond Earth. Let's dive in. 2 weeks ago, NASA did something that seemed almost routine, except it wasn't routine at all. The team at Kennedy Space Center successfully fueled the Space Launch System rocket with 2.8 million liters of propellant. That's 730,000 gallons of super cold liquid hydrogen and liquid oxygen loaded into tanks the size of buildings, while keeping hydrogen leak concentrations well within safe operational limits. Why does that matter? Because the last time they tried, it didn't go so well. About 2 weeks earlier, the first wet dress rehearsal, which is NASA speak for a full dress rehearsal of launch operations, got cut short. A liquid hydrogen leak showed up at the tail service mast umbilical. Same exact spot where Artemis I had problems years before. So the team had to pull everything apart, replace seals, and try again. This time, it worked. That successful fueling test wasn't just about loading propellant. During those 2 days, the mission team put the entire SLS rocket and Orion spacecraft through an exhaustive series of pre-launch procedures. They closed the Orion crew module hatch. They verified the emergency escape system. They ran through 2 simulated terminal counts, advancing the countdown clock all the way to T29 seconds, where automated systems took over, flight computers executed their final checks, and the rocket transitioned to internal power. There was a brief hiccup during the second countdown, a booster avionics voltage issue that caused a pause. But they worked through it, and when everything was said and done, NASA had clear evidence that the hardware, the ground equipment, and the personnel are ready for human flight, which means Artemis II could launch as soon as March 6th. Let's talk about what this mission actually is. Artemis II will be the first crewed spaceflight beyond low Earth orbit since the Apollo missions ended in 1972. It's a 10-day journey covering more than 685,000 miles. 4 astronauts, NASA's Reid Wiseman, Victor Glover, and Christina Koch, plus Canada's Jeremy Hansen, will ride the SLS to Earth orbit, then continue on to lunar orbit, swing around the far side of the moon, and return home. They won't land. That comes later with Artemis III. This mission is about something different. It's about proving the system works with humans aboard. It's about gathering critical data on human health in deep space. It's about observing the lunar far side up close. And it's about practicing the flight maneuvers that'll be necessary for the actual lunar landing missions that follow. These aren't rookies, not even close. Wiseman's been to the International Space Station twice. Glover flew the Space Shuttle. Koch spent a year on the ISS, the longest single spaceflight by any woman. Hansen's an experienced test pilot who's logged thousands of hours in high-performance aircraft. They've trained extensively for this moment, and they're ready. The launch windows are actually pretty tight because of orbital mechanics. You need the moon and Earth to be in specific positions. You need the right lighting conditions for the crew to see where they're going. You need the trajectory to work. It's not like launching whenever you want. The primary window runs from March 6th through March 9th, with another opportunity on March 11th. If those don't work out, there's another window in early April. But here's the thing, everyone's hoping for March. The Space Launch System, the SLS, is NASA's heavy-lift rocket. We're talking about the most powerful rocket NASA has ever built. The core stage alone is a marvel of engineering. It's got four RS-25 engines firing simultaneously. Each one produces 418,000 pounds of thrust. These aren't new engines. They're actually upgrades of the Space Shuttle main engines. Proven hardware, but enhanced and validated for deep space missions. Then you've got the solid rocket boosters on either side, providing additional thrust during the first 2 minutes of flight. They give you the raw power to overcome Earth's gravity and accelerate the payload to orbital velocity. After they burn out, they separate and fall away. The core stage continues burning. And then the interim cryogenic propulsion stage, the upper stage, takes over and pushes the Orion spacecraft toward the moon. Nothing gets near that launch pad without proving itself first. The core stage was manufactured at the Michoud Assembly Facility in New Orleans. It was tested exhaustively at Stennis Space Center in Mississippi, where engineers ran hot fire tests to verify every system. The RS-25 engines went through their own qualification tests. The solid rocket boosters were manufactured by Northrop Grumman and tested independently. Thousands upon thousands of hours of testing and validation happened before any of this hardware ever came near Kennedy Space Center. Now let's talk about Orion. It's the spacecraft where the crew actually lives and works. The crew module is a cone-shaped capsule that houses the four astronauts. It's pressurized, shielded, and equipped with everything they need to survive the journey. The European Service Module, built by the European Space Agency and Airbus, provides propulsion, power, water, and oxygen. It's an international partnership, and it's essential to the mission. Orion's life support architecture is built on closed-loop systems. The spacecraft recycles water. It manages carbon dioxide removal. It maintains oxygen levels. It regulates temperature and humidity. These aren't simple systems. They're sophisticated pieces of hardware that have been tested extensively in the Orion Integrated Test Lab and validated during the Artemis I mission. The crew will have water, food, and oxygen managed through automated systems with manual backup options. The carbon dioxide scrubbing system removes CO2 from the cabin atmosphere. Thermal control systems manage the extreme temperature swings between sunlit and dark sides of the spacecraft. So when you're sitting in that capsule, hurtling through space at 25,000 miles per hour heading toward the moon, you're depending on systems that have been validated and revalidated and tested again and again. That's not paranoia, that's engineering. 4 people. 10 days. Nothing but a thin metal shell between them and the vacuum of space. That's where life support systems become absolutely critical. Here's something fascinating. NASA's running programs with acronyms like ARCHER and AVATAR to study immune biomarkers and predict how radiation affects the crew. ARCHER stands for Artemis Research for Crew Health and Readiness. Scientists are studying how the deep space environment, especially radiation, impacts human physiology. AVATAR is a virtual astronaut tissue analog response system that helps predict how crew members will be affected by the radiation exposure during the journey. That's not theoretical stuff. During Artemis II, the crew will wear radiation dosimeters. Sensors inside the Orion capsule will continuously monitor radiation levels. Scientists back on Earth will gather data in real time. Some of that data will inform decisions about future lunar missions. Some of it will help us understand how to protect crews on even longer journeys, like trips to Mars. But radiation isn't the only concern. You've also got the psychological and physiological impacts of being in deep space. The crew will be farther from Earth than any human has been since the Apollo missions. Communication delays will increase, the view of home will be smaller, the sense of isolation will be real. That's why the training is so comprehensive. The astronauts have trained in simulators that replicate the Orion environment. They've practiced emergency procedures. They've studied the lunar far side, the part of the moon that faces away from Earth. They've learned the system so thoroughly that they could operate them in their sleep. And they've trained as a team, building the cohesion and trust that's essential when you're that far from home. Hey, real quick, if you're enjoying this dive into space exploration, do me a favor and hit that subscribe button and turn on notifications so you don't miss the next episode. This stuff moves fast and you'll want to stay in the loop. None of this happens without the physical infrastructure at Kennedy Space Center. Launch Complex 39B is where the magic happens. This facility was originally built for the Apollo program. It's been modified and upgraded countless times over the decades. It's hosted space shuttle launches. It's hosted Falcon 9 and Falcon Heavy launches from SpaceX. And now it's hosting the Space Launch System. Launchpad 39B has a mobile launcher, essentially a tower that moves on crawler transporters the size of small buildings. This mobile launcher connects to the rocket through a series of umbilicals that supply fuel, water, power, and communications. The sound suppression system channels millions of gallons of water across the pad during launch to dampen the acoustic energy that would otherwise damage the vehicle and surrounding facilities. Lightning protection systems stand ready. The flame trench beneath the launch pad directs the rocket exhaust safely away. The Exploration Ground Systems team manages all of this. They've integrated hardware from multiple contractors: Boeing, L3 Harris, Northrop Grumman, Aerojet Rocketdyne, into a cohesive system. They've run simulations. They've practiced launch countdowns. They've validated every procedure. When launch day arrives, they'll execute a sequence that's been rehearsed dozens of times. But here's what makes Kennedy Space Center special in this moment. It's not just hosting NASA. SpaceX launches Falcon 9 and Falcon Heavy from adjacent pads. Blue Origin is developing launch capabilities nearby. The entire facility has become a nexus of American space activity. It's a place where government and commercial space industries coexist and share infrastructure. And that's a big deal. While NASA's preparing for crewed lunar missions, something extraordinary is happening in the commercial sector. SpaceX is launching constantly. We're talking about multiple launches per month. Falcon Heavy, their largest rocket, is deploying massive payloads to orbit. Starship, their next-generation super heavy-lift vehicle, is undergoing test campaigns that push the boundaries of what's possible. Recent tests have achieved booster catch success and advanced the vehicle toward orbital refueling capability. Other companies are accelerating too. Blue Origin is ramping up New Glenn. Relativity Space is testing 3D-printed rockets. Axiom Space is planning the first fully private space station missions. VAST is being selected for private astronaut missions to the ISS. The commercial launch cadence is surging to meet demand that's unlike anything we've seen before. Here's the wild part. Infrastructure is becoming a bottleneck. Space launch facilities at Vandenberg Space Force Base are exploring more launch pads to meet demand. Kennedy Space Center is managing increased traffic. The commercial industry is literally outpacing the physical infrastructure's ability to support it. Companies are launching multiple times per month. That requires more pads, more support equipment, more ground personnel, more logistics. It's not competition. Well, it's not only competition. It's a fundamental shift in how humanity approaches space exploration. NASA's leading with Artemis II. But the entire sector is moving in the same direction: deeper, farther, longer. And the commercial industry is enabling that by making launch more frequent, more reliable, and more routine. That's actually essential to what comes next. Because lunar exploration requires lots of launches, you need to send cargo. You need to send equipment. You need to send fuel. You need to establish supply chains. That's not something NASA can do alone. It's something that requires the entire industry working together. Oh, and if you're watching on your phone, there's a hype button right below the video. Smashing that really helps smaller channels like ours get discovered by more people who are interested in this stuff. NASA's lunar exploration roadmap lays out an ambitious vision. Artemis III will actually land on the moon, specifically at the lunar South Pole, an area that's been largely unexplored. We're talking about a region shrouded in mystery but holding enormous scientific potential. There's water ice there. There are permanently shadowed craters. It's a completely different environment from where Apollo landed. Those Apollo missions, they went to the equatorial regions. They were flag and footprints missions. We're not talking about that anymore. We're talking about building infrastructure. We're talking about establishing a sustained human presence. We're talking about preparing for longer-term exploration and eventual human missions to Mars. Artemis III will land a crew at the South Pole. They'll spend time on the surface. They'll conduct scientific investigations. They'll test technologies for longer duration surface missions. And then, Artemis IV, Artemis V, and beyond. Multiple missions, multiple landing sites, building towards something bigger. Europe's contributing too. The European Space Agency is developing Argonaut, a lunar lander program that'll support European participation in lunar exploration. It's part of the broader international coordination happening through the Global Exploration Roadmap. Space agencies from around the world, NASA, ESA, JAXA, Roscosmos, CNSA, and others, are coordinating their lunar ambitions. It's not a single program. It's a global effort. Private companies are getting involved too. Multiple lunar lander companies are being developed. Multiple companies are planning missions to deliver cargo to the lunar surface. The lunar economy is starting to form. It's not science fiction anymore. It's happening now. And here's the really important part. All of this, Artemis II, the commercial launch surge, the lunar infrastructure development, the international coordination, it's all preparation for something bigger. Mars. Human missions to Mars require technologies that we're developing and testing right now. Life support systems, deep space navigation, in situ resource utilization, long-duration habitat operations, all of it is being tested and refined through the lunar program. We're living in the era when humanity is preparing to become a multi-planetary species. Artemis II is a critical milestone on that journey, but it's not the destination, it's a waypoint. Here's what's remarkable about this particular moment in history. Everything's converging. You've got NASA executing the most ambitious crewed mission since Apollo. SpaceX is ramping up commercial launch cadence and testing Starship, which could eventually carry people to Mars. Europe's building lunar modules. Private companies are planning space station missions. Satellite mega-constellations are expanding into orbit. International space agencies are coordinating through the Global Exploration Roadmap. All of this is happening simultaneously. And it's not random, it's coordinated. NASA's Artemis program is pushing innovation. That innovation trickles down to commercial providers. Commercial providers are developing capabilities that NASA will eventually use. It's a symbiotic relationship. The timeline is aggressive. Artemis II could launch in March 2026. Starship continues its test campaign. European lunar modules are in development. Private space station missions are being planned for 2027. Artemis III is being targeted for the late 2020s. The Lunar Gateway, an orbital outpost around the Moon, is being developed. Everything's building towards sustained lunar presence and eventual human Mars missions. But here's the tension. Space is unforgiving. NASA won't rush this. Every system has to work. Every procedure has to be validated. Every contingency has to be planned. That's why the wet dress rehearsal was so important. That's why they replaced seals and tested again. That's why they ran terminal counts twice. You don't get a second chance in space. You get it right, or you don't get to go. That same discipline applies across the industry. SpaceX tests extensively. European agencies validate thoroughly. Private companies understand the stakes. This convergence of missions isn't reckless. It's ambitious, but it's grounded in rigorous engineering and proven processes. And that's what gives us confidence that 2026 is really the year. Artemis II is coming. The lunar era is beginning, and humanity's preparing for something even bigger beyond that. That's what's happening right now in space exploration. Artemis II represents a pivotal moment, the return of crewed deep space missions after more than 50 years. But it's also a symbol of something larger, a global effort to explore beyond our world, to understand our place in the cosmos, and to prepare for humanity's expansion to other worlds. The hardware is ready, the crew is trained, the infrastructure is in place, the entire industry is aligned, and the countdown is ticking toward March. Thanks for joining me on Tomorrow Unveiled. If you found this fascinating, please hit that subscribe button and turn on notifications. Share this with someone who'd appreciate it. And let me know in the comments what aspect of space exploration fascinates you most. I'm your host, and I'll be back next week with more stories about the future that's unfolding right now. Until then, keep looking up, looking.
Let the future be your guide with all the